Have you ever looked at a solid block of metal and thought, could I do a magic trick with that? I don't mean bending it or just melting it. I mean truly transforming it into something completely different, something kind of magical. Well, let's get into it, because today we're looking at a technology that does exactly that. So, here's the big question we're going to tackle. How in the world do you take a heavy, solid block of metal and turn it into this incredibly fine powder? A powder you can then use to 3D print things like jet engine parts or custom medical implants. It sounds almost impossible, right? But the answer is just fascinating.
To figure this out, we have to start with the end goal. And it's a fun one. We're not just making any old metal dust, we're trying to create what the source material cleverly calls metal sugar beans. And that name, believe it or not, is the perfect place to start.
The official term is metal atomization, but honestly, the best way to get it is to just picture this. Imagine you're blowing melted chocolate through a super high-powered fan. That liquid chocolate would just explode into millions of tiny little drops, and they'd freeze instantly into little chocolate particles. Atomization does the same thing, just with molten metal. Pretty cool?
And when I say tiny, I really mean it. These little metal particles are usually somewhere between 15 and 150 microns across. Now, to give you some perspective, a single human hair is about 70 microns wide. So yeah, we are talking about a powder that is unbelievably fine, which is absolutely critical for what it's used for.
Okay, so how do they actually pull this off? How do you make these perfect little metal spheres? Well, it all happens in what the source calls a high-pressure transformation. Here's the key idea to hang on to. The whole process basically works like a giant high-pressure water gun. Except, instead of water, it's firing out liquid metal with incredible force. On paper, the process is actually pretty straightforward. First, you melt the metal in a super hot furnace. Second, as that liquid metal streams out of a tiny nozzle, it gets blasted by jets of high-pressure gas. The impact is so violent, it just shatters the liquid into a fine mist of tiny droplets. And third, these droplets cool almost instantly as they fly through the chamber, solidifying into that perfect powder. This quote from the source material just nails it. The physics are exactly the same as blowing soap bubbles. Your breath is the gas, the soap film is the liquid, and you break it apart into tiny spherical bubbles. It's the same idea here, just a whole lot hotter and more powerful.
But wait a minute, why not just use regular air? It's cheaper, right? Well, that would be a complete disaster. Blasting hot metal with oxygen would cause it to oxidize immediately, think instant rust, and it would totally contaminate the final powder. So the solution is to use an inert gas, like nitrogen or argon. It acts like a protective shield, making sure the metal powder stays incredibly pure. This all seems like a lot of work, doesn't it? Melting metal, blasting it with expensive gases. So why go through all this trouble? Well, let's talk about the perks, because this perfect powder is seriously valuable. It really comes down to 3 huge advantages. First, high sphericity. Because those little droplets form in midair, they end up as nearly perfect little spheres. This means the powder flows like a liquid, smoothly and predictably, which is exactly what you need for a high-precision 3D printer. Second, as we just talked about, you get super high purity. And third, the size is controllable. You can just tweak the gas pressure to make the powder finer or coarser depending on what you're making.
And this isn't some niche process. Get this, it accounts for about 40% of all the metal powders used in 3D printing. And that number shoots way up when you start talking about high-performance stuff, like the titanium and nickel superalloys used in the most demanding industries out there.
Now, you might be thinking this is all super industrial, something you'd never actually encounter. But this technology is probably way closer to you than you think. Let's see where atomization pops up in your life.
Every time you fly, there's a really good chance you're being kept safe by parts that began as this exact powder. The aerospace industry uses it to 3D print incredibly complex and lightweight, but super strong components for things like jet engines and aircraft frames.
It's also a game changer in medicine. That high purity and precision make this powder perfect for creating custom medical implants, things like artificial hip joints or dental implants that are perfectly tailored to a specific patient's body. And yep, if you look deep inside the phone in your hand or the computer on your desk, you'll find it there too. Atomized metal powders are used to make some of the tiniest, most precise electronic components where consistency is absolutely everything.
So this technology is already here and it's making a massive impact. But what's next? Because for all its power, the process isn't perfect. And that's where the future really begins.
As amazing as this whole thing is, it's got some big challenges.
The equipment is incredibly expensive. Melting all that metal and compressing all that gas takes a huge amount of energy. And of course, all that special inert gas isn't cheap. These are the main hurdles holding it back from being used even more widely.
So the goal for the future is pretty straightforward. Make the powder cheaper, purer, and even finer. And scientists are already working on it, exploring things like using ultrasonic vibrations to help break up the metal more efficiently, or designing smarter nozzles that use less gas to get the job done.
So when you step back and look at the whole process, it really is a kind of metamorphosis. You start with this simple, solid block of metal, and through this incredible blast of heat and force, you end up with a universe of tiny, perfect spheres, each one ready to become part of the next big thing.
Which really just leaves us with one final, exciting question. We're already building jet engines and life-saving implants. So, what's the next big thing we're going to build? One tiny metal drop at a time. The possibilities, they're truly endless.